was we had started looking at just a review of like Pythagoras and trigonometry and stuff. So now we're going to be kind of starting to hammer in on some of the newer stuff here. Specifically, we're going to start looking at, I think it's on page 179. Yes, 179. We're going to be start looking at specifically triangles. And also, like at this point, you should be, pretty good with right angle triangles. But what if we give you a non-right angle triangle? Well, if you give you something like this, you could probably figure it out because, oh well, if I just do this, now I have two right angle triangles, right? But what if I was to give you, like a triangle, like, something like something like that? Maybe not so much. You look at this triangle down here, maybe not so much. So our options can kind of change here a little bit once we actually change the type of triangle we get. So how do we know something's a triangle? It sounds like a really easy question, but I've taken college level classes about like proving something's a triangle. How do you know it? It has three sides. It's a closed figure. That means like it's all the sides are touching the other side. And the interior angles add up to 180, right? Because you have three angles in any triangle. You add all three of those up, you'll always get 180. None of that's new information to us. Now, you've probably also seen these types of triangles before as well. You've probably seen an acute triangle where all three of those angles are less than 90 degrees. So you have a smaller one, right? 90 degrees is, again, where you just go straight up from a straight line. Smaller than that would be where you don't get that. So maybe, this one's, 70, 50, and, 60 or something. Right angle triangles, we know what that is. We know one of those angles is 190 degrees. We represent that with a little box. And the other type of triangle we can get is an obtuse triangle, where one of these angles is bigger than 90 degrees. It's a larger triangle. So those are the three different kinds that we can get. Now there's also, so that's by when you look at the angle measure. You have acute, right, and obtuse. We've also seen these before at some point in our lives. We have equilateral, isosceles, and scalene triangles. So different triangles can have different properties, right? So with this one here, equilateral triangles, well, that means that all three of these sides are the same length. Maybe this one's 10 centimeters, this one's 10 centimeters, and this one's 10 centimeters. And we represent that with these little lines here, right? Now, so all three of these have the same line. That means they have the same length. And if all three sides have the same length, that means that angle's the same. So an equilateral triangle, you have the three sides have the equal length, and the angles are also the same. Now we also have the isosceles triangles. This is where only two of those sides are the same. And you can see that by these two lines here. And because these two sides are the same, these two angles are the same. So we have different ways to kind of show that without stating it with words. Again, if you think way back in the old days, you didn't really have a lot of paper. It wasn't very easy to be able to find something to write stuff down. You had to represent it very, very concretely in a short amount of like space. So how do we do that? Again, these lines show that these two sides are the same length, and these lines here show that these are the same angle. Now, if I were to give you another angle like here, you see I have two lines up here. They're different. This is saying that, hey, this angle is different. If I give you two lines down here, it's saying, hey, this line here is different than these two up here. They have different markings. So there's different ways of kind of representing this. So again, equilateral, everything's the same. Isosceles, two angles and two sides are the same. And then we have a scalene triangle, which means all the sides have different lengths. All the angles have different measures. So we have three different kinds of triangles by the angles and three different kinds by the sides. So you can see that there's quite a few number of combinations you could probably make with this. I could have a scalene. Let's zoom out for a bit. I could have a scalene right triangle. I could have a scalene obtuse triangle. I could have an isosceles acute triangle, or an isosceles right triangle, for example. So there's different options you can generate with that. So how does this actually work out then? Well, now what we have to do is we have to use information generated specifically by these angles, by the length of the sides, and by the qualities of these different triangles to be able to figure certain stuff out. So let's say, for example, if I look at this triangle right here, the question I have for you is, what type of triangle is this? I'm looking at the whole shape, the big one.
Would be the acute one.
So this one here. So yeah, let's look at the angles here. So so acute would mean all three angles are less than 90 degrees. That seems right. That seems like it's an acute triangle. So I'll use the same colors here because I'm going to use two different ones. So in terms of the red triangle, it seems like it's acute. But then what about the sides? What do we see with that?
Isosceles.
It's an isosceles, right? We see that we have these same markings here. So it's an acute isosceles triangle. Now we can use this to generate information. The important thing here is not that, aha, it's an acute isosceles triangle, we've solved it. The important thing is, okay, I know these two things. What can I generate from that information? Well, if I know if it's an isosceles triangle, if I know these two sides are the same, that would mean that these two angles here would be the same, for example. If I were asking you to find this angle, you could do that. You could do that information now. Just, but well, if I know this one's 53 degrees, it's an isosceles triangle. This one would also have to be 53 degrees. So we can find that information based on the properties of the triangle. So let's try actually diving a little bit deeper into this. I'm going to erase all my markings here. Okay. So the first question is asking us, what's the length of side BC? What does that mean? Like this BC thing, it means that literally the length of B all the way to C, if you were to draw a line from it, which is what that bottom side is here. So we're trying to find the length of this red line. My question for you is, how the heck do I do it? It's not a very easy question, right? And so when we're looking at this, we have to try and use pieces here. So here's what it is. I could probably, if I'm looking at this, let's use blue. If I'm looking at this blue triangle here, do I know two things about this triangle?
It's 16 and 20.
16 and 20. I also know, I actually know a third thing. I know this one's already 53 degrees here too. So I know a couple things about this triangle. I can use that to find missing pieces. If I'm going to, I'm going to use a dark green color here. If I look at this green triangle, do I also know two or more things here?
Yeah, B and H.
Yeah, I know the angle, I know this. So I know two things about each triangle. I can find the other information about the triangle now. The second you know two things, you can always find more. So my question is, well, what do I need to find? If my ultimate goal here is I want to figure out what the length of BC is. Well, if I could take this blue triangle, if I know these two sides, I can use that to figure out this side. And if I know two things on the green triangle, I can use that to find information on this side.
Oh, okay, so,
And then I can just combine them, right?
so then would it be? Would it be sign that you would have figured that out?
Oh, you're looking at the trig with this one? Oh, with the blue one?
Yeah.
Oh, I'm using two sides to find a third side. So that would be Pythagoras there.
Pythagoras,
Yeah.
okay.
So before we even start going into it, so we're already thinking like how we can solve this. Let's put some math, like I like put in like, how do you solve this in the plain English at the start? Basically, we're going to find the length of CD. That's the bottom of that blue triangle. And the length of BD. That's the bottom of that green triangle, right? And we're going to combine them. We're going to, we'll use even simpler. We're going to add them, right? That's how we actually solve this in plain English. Find the length of side CD, find the length of side BD, combine them. So it's going to be important to us first to organize this work, not necessarily for this question, but for a future question, yes. So I'm going to do CD. I'm going to find this blue one here first. And we've already figured out how we can do that. I'm using two sides of a triangle to find a third one. I need to use Pythagoras, which is a squared plus b squared is equal to c squared. You know what? I'm actually going to go to my bottom page here and do that. I'm going to put that down here. A squared plus b squared equals c squared. And so now if I'm looking at this triangle up here, the blue one, I already know my hypotenuse, right? I know that B is my hypotenuse.
Yeah.
The 20 centimeters is my hypotenuse. So I'm going to start substituting stuff in, right? What was the other one? Was it 16?
6.
Yeah. So 16 squared plus, I'm just going to leave it as, I'm going to put X because it says X in there. Plus B squared equals 20 squared. Let me make this a little thicker. So remember this is now an algebra thing. My ultimate goal is I want to know, hey, what's X? What's that side equal to? I want it to tell me that. So what do I need to do? I need to get rid of the stuff attached to that. I need to get rid of the 16 squared. And I could square it out first. I could do that if you want, totally fine. But I need to do the opposite of what's happening. Right now, 16 squared is being added to X. I know I need to get X by itself. So I'm going to do the opposite of adding 16 squared, and I'm going to subtract 16 squared from both sides. And what's going to happen? That gets canceled out. It gets brought over here. And I write it in exactly how I see it again. So now it's X squared is equal to 20 squared minus 16 squared. So I'm still using those same steps from yesterday, right? Which formula do I use? Substitute, solve. So at this point, I can just let my calculator do all the heavy work for me. 20 squared minus 16 squared. It's going to give me 144. Right. So, and again, this step right here, you could completely skip if you know what you're doing, but it's technically X squared equals 144, which we then need to take the square root of, right? Because it's X squared, I need to do the opposite of squaring, which is the square root. And if I do that, square root of 144, I'm going to get 12. So the length of that side is 12 centimeters. That's the length of CD. Now, again, we've already established how to solve this. We already shown that, hey, I find CD, check, and then find BD and add them. Now, you could use trig to find this. You know that this is 16. You know this is 53. What's this? This is your opposite side. This is clearly a right angle here. So this is your hypotenuse. This is your adjacent. You could use the tangent stuff here to figure this out. And it would give you the right answer. But if I erase all this again, let's look at a clean triangle. What type of triangle is this again? Acute and isosceles, right? And if it's acute and isosceles, well, if that's the case, these two triangles, the one on the left and one on the right, they're the same thing. Because these sides are the same. We know that these angles are the same. We know this angle's the same. They're the exact same triangle, right? So if this is 12, that means this has to be 12. So you could do it this way, and you'd still get full marks for that. You could do the trigonometry with that. But if you notice it's an isosceles triangle, so like, well, if I know that, I know the angles are the same. I know that these angles are the same, which means this is something, if this is 53, this is 53, 180 minus 106. It's going to give you 74. This whole angle 74, you cut that in two because it's split directly in half, you'd get 37. It's the exact same triangles, which means you'd then know that, oh, well, it's just 12 and then another 12. So to actually find it, what do we do? It's just going to be 12 centimeters times 2. So the whole length of BC, in fact, I'm going to put that in here. BC is 12 centimeters times 2, which is 24 centimeters. Now, this question was a two-parter. The second one, so we've done step one, or part A. We know that the length of BC is 24 centimeters. The next thing here is, well, it wants us to classify by angle measure and by side length. Well, what the heck does that mean? Well, when we classify a triangle, there's a couple things we need to put. We need to know we need to classify it by angle, which we did. It's acute. We need to classify it by side, which we did. We know it's isosceles. It's an acute isosceles triangle. We need to find the angles. We need to find the we need to find the angles. We may need to find the sides. That's only if we need to actually use that to find the angles. So basically what we're trying to do here, our goal when we try and classify a triangle, because that's what the question asks us, is what triangle is it and how do you know? What triangle is it and how do you know? So this is technically notes here. This is not how you're going to solve it each time. So the actual solve, the answer is going to be, I'm going to put this little triangle symbol here because this represents that it is a triangle. Triangle ABC, because that's what it is, right? Those are the three sides that form the big triangle. Is an isosceles. It's an isosceles triangles. I've made a claim. This is what it is. How do I know it? How do sorry. So I've said it's an isosceles triangle. How do I know it's isosceles? Because
That's two sides.
yeah, two sides have equal length would be the formal mathy way of saying it. These two sides have equal length. And we know that because it has the lines there, right? So ABC is an isosceles triangle because the two sides have equal length and the two, we call them interior angles, the ones inside, we'll learn more about that later, are equal. Right? We know it's an isosceles triangle because two lengths are equal, two sides are equal. This is a very formal way of wording it. And that's usually the challenging part is how, like, it's obviously a triangle, right? It's trying to show your evidence. So we've established the angle, and now we need to establish the side. So it's also, so triangle ABC, I'll write the triangle, actually let's draw it now.
We have to like write down this all
No, so,
on like the test.
just this part I'm kind of in blue, but yes.
Okay.
Yes. Yeah, you're saying, hey, this, like, you're basically saying, what's the sides, what's the angles, how do you know? You could make this less wordy if you wanted, but it does need to essentially be a full sentence. So again, I've established that it's an isosceles triangle. I've also established it's an acute triangle. Is an acute triangle because all of the interior angles are less than 90 degrees. So the stuff with the blue line here would actually be the answer. The stuff above that is just like kind of just some notes about what does it mean to actually classify a triangle. And again, this is still a wordy way of doing it. You could say it's an isosceles acute triangle because all the angles are less than 90 degrees and you have two equal sides and two equal angles. And that would be fine too. So like I said, like this is very wordy, but you can simplify it if you need to. And we'll practice making this as short as we can with the next one. So let's take a look at this next one here. Question 4, which is we have a following diagram here. We have triangle MNP. And it wants to know is, hey, what's the measure of this is angle M is what this actually means. What's the measure of angle M? Which is this. Hey, just what's the angle of that? And now there are going to start being multiple ways to solve this. There's 2 ways you can solve this question. Can anyone think of like one of the ways?
You could subtract all the degrees from like 180, because if that one is 60, shouldn't the other one be 60?
So you're saying this is 60 degrees? How come?
Because-
Yeah, so you're right. This would be 60 degrees. So how can you use that to figure out angle M then?
Because they should all equal 180.
Would it be just 60 minus 30? There it is. 90 minus 60.
Oh, you're on the right track. So we know all three angles of a triangle. So you're right. This is 60 degrees because it is isosceles, as you said. Those lines mean that, which means these angles are the same. And because we know that all three angles of a triangle need to be 180, I know that there's 180 degrees in a triangle. And I know that I have two of them that are worth 60. So if I take away these two from that 180, I'm going to be left over with whatever my answer is. In this case, it would be 60 degrees.
Oh,
Yeah.
So a right triangle is 90 and the whole triangle is 180.
Well, even in a right triangle, all three of these angles would still add up to 180 degrees.
Okay.
Yeah. Yeah. It's just saying that a right triangle just has one triangle with that 90 degrees. But so yeah, so what's the measure of angle M? It's 60 degrees, right? So that's one of the ways, and that's probably going to be the easier way, because the other way you could solve this would be, well, okay, I'm not sure, but maybe if I split this in half, what am I going to do? I turn it into two right triangles now. All of a sudden, I know, oh, this side's 15 meters. It looks like it's isosceles, which means this one must be 15 meters. So now I have two things. I have a side and I have an angle. I can figure out another side. Let's say I'm just going to pick this one because why not? And then I could use two sides to find an angle. You could do it that way. Obviously, that's a lot harder though, right? So knowing the properties of a triangle is quite helpful. Now, the next thing it's asking us is, it wants us to classify this by angle measure and side length. Well, here's what we know. We know that all three of these angles are 60 degrees. So I know it's going to be an acute. So triangle MMP we know it's an acute triangle. And now the goal of this here is we're going to try and summarize this as quick as we can. We know it's an acute triangle. What about the side lengths? What type of triangle is that? So it is isosceles, but if all three angles are the same, that would also mean that all three sides have the same length too. So it's actually an equilateral triangle. So I've classified it and now I just need some proof, right? So I've classified it. What's my evidence? All angles are less than 90 degrees. And all sides have the same length. So you can condense that information quite a bit. You could even condense this further if we wanted, actually. We could even just say all the sides and all the angles are the same because it's equilateral. So I got two questions here, question 5 and 6. I'm going to give you guys like, about 3 or 4 minutes here to try those two out. This is a chance to like kind of try this stuff, ask for help if you need it. So 3 or 4 minutes, try out question 5 and 6. That's these. So wants us to find the length of PR, which is this one here, right?
Yeah.
So if I have two different triangles here, let's say I have triangle 1 and triangle 2. So here's what I know. I know that this side here, QR, is 8 meters.
Yeah.
I can see how we have the same lines here, which means that this must be 8 meters as well. So if that's the case, well, if this is 8 meters, this is 8 meters, two sides are the same, we have a isosceles triangle, which would mean that these two angles here would be the same as well. So there's a couple ways we could solve this. So one of them would be, well, okay, so if I know that these two angles have the same amount, I know this whole triangle, P, Q, and R is a right triangle. If these two sides are the same, these two angles are the same, we could divide this by half. This is probably, this is 90 degrees. This is probably an equal cut in half, which would mean both of these could be 45 degrees. We could make that assumption. That's one way to think about it. Now, the other way to think about it is I have a right triangle. I know two sides and I'm trying to find a third side. So what could I do then with that information? Like if I'm using two sides to find a third side,
Oh, Pythagoras here.
I could use Pythagoras, right?
Oh, okay.
Yeah.
Two sides, yeah.
Yeah. So if you have two sides trying to find another one, a squared plus b squared equals c squared. I know that the one I'm trying to find is my hypotenuse, which would mean that this would just be 8 squared plus 8 squared. Or 64, 128 sounds right.
So this would be an acute.
So this one here. So this is triangle P, Q, and R. So we can either be acute, it can be right, or it can be
Oh, you were saying it was a right triangle.
yeah. So this
Right.
yeah. So this would be a right triangle, would be the angle measure, and then what you want to figure out the side measure. Basically, you know it's at least isosceles. Your goal there as well is it you're trying to figure out, well, it's not equilateral, right? Yeah, in this case, this would be, we know it's a right triangle, and we know it's also a isosceles. It is not equilateral because one of these angles is different. So right away, that already tells us, and we already know that this side is different too. So we know it can't be equilateral, but we know it can be at least isosceles. And then you can put your, your reasons below. I won't necessarily do that. The big thing is you can recognize what type of triangle it is. So I'll give you about another 2 or 3 minutes there. So when you're looking at yeah, so triangle QRS, that's that red one there. Like it's kind of, I find it quite helpful to actually draw an outline around it personally when there's multiple. So you're looking at this triangle. What do you think this angle here is? Angle, I guess, S on this?
The angle,
Yeah.
the 90.
Yeah, so this one, you're right. This one here would be 90 degrees.
Okay.
Yeah, so you know it would be a right triangle then. So we know it's a right triangle. And then we're looking at the sides. It can't be equilateral because this is right and these are not right angles.
Yeah, isosceles.
It would be isosceles though, you're right, because this angle here would definitely be the same as angle R. So you get something like that. So yeah, this would be a right isosceles. And you could add the reason in, later. Again, this is just blah, blah, blah. Here's my reason. Yeah, so again, use Pythagoras because you know that this side here is 15 because it's half of this. You use that Pythagoras to find the length of that height, and then you can just use your formula to get the area. So kind of a tricky question, right? So this stuff gets quite difficult because you're using multiple triangles. There's multiple ways to solve stuff, and you got to try and like figure out, what is probably the best way. So it can be used a lot of different ways. So if I give you something like this, for example, so this is example 4. So what we have is we have an asymmetrical roof that has sections that are 18 feet and 14 feet long, right? So 18 feet, 14 feet, and the roof has a rise of 6 feet. So the question it asks us is, well, how wide is the building? So how wide is the building? What does that actually mean? Like, what am I actually trying to find? The width of the building, which would be the length between which 2 points?
Would it be B and D?
Yeah, it's actually what it actually wants me to do is it wants me to find B and D. Now, what would probably, so if it wants me to find B and D, that's the same thing as B and C and C and D, right? You're almost always going to have to solve each individual triangle separately and then add it up together. 99% of the time, that's going to be the case. So you can just assume you're going to have to split that up. So let's actually try and find the length of that, the width of that building. So we're going to go down here. So this is question A. So how can I do that? Well, I already established I need to figure out 2 things, the length of B and C and the length of C and D. Now, which of these 2 triangles, triangle 1 or triangle 2, looks like it's probably easier to start out with? But we'll probably C and D, probably triangle 2, right? It has more stuff to work with. We always need 2 things, is really what it boils down to. So if that's the case, triangle triangle 2, we're trying to find angle C or length C and D first. I'm going to write that there. How can I do that?
Pythagoras.
I could use Pythagoras. I could also use trigonometry too. I have an angle in there. Doesn't matter which one you use, whatever you prefer. I'm going to use Pythagoras here just because I know that 14 is my hypotenuse. So I know it's going to be a squared plus b squared equals c squared. I know that one of those sides is 6. The other side, I'm not sure. I'm going to leave that as B. And I know that the hypotenuse was it 18? 14. So if you start solving that, right, so b squared is going to equal to 14 squared minus 6 squared, right? Because I subtracted 6 from both sides, which would give you 160. Oh, sorry, minus 6 squared. So yeah, 160, you square root that. Going to give you 12 point. Yeah, let's say 12.6. 12.6 feet. Yes. So that's one part here. So that's B. So again, you notice like I kind of like skip some steps in my work, but you can still float like see this, right? This is totally fine. You can see exactly where it's going to. So I've already solved one part. I've solved CD. The only thing I need to find now is
B and C.
B and C. So I'll give you a second to write this down. If you finish it, just try and think, how could I find B and C is our next kind of goal. So how can I find the length of B and C?
Tree.
So which angle do I know on there? Beside the, so you're right, it is a right triangle, you're right.
Would you go 90 minus 25?
So if you're trying to figure out this angle here, you could do 180 minus 90 minus 25.
Oh,
So that would give you 75. So this angle here is 75 degrees. The problem is we don't actually know how big this full angle is. If this was a right triangle, if this was a right angle here, you could use that information.
right.
So we don't actually have an angle to work with, but here's what we do know about this. I know the height of this line and I know the length of this line.
So we just do Pythagoras.
You could use Pythagoras again, yeah. Because we don't, this one's definitely not an isosceles triangle. So like before, we've always been like, oh, this is the angle. We don't actually know that in this case. So you're right, we would use Pythagoras here, just like before. 18 is my hypotenuse, so just like before, where it's really going to end up with, it's going to be a squared plus b squared. It's going to be equal to c squared. And it's going to end up being just like before, 6 squared equals 18 squared. It's just to repeat some slightly different numbers. A squared is going to be equal to 18 squared minus 16 squared. Sorry, minus 6 squared. Which would give you 288. And then you square root that to get, looks like about 17.
Together.
And then you just add them together. That's right. So again, this is why it's very, I really, really like, I'll come down to this in a second. I like putting in exactly how to solve it, which is you have to go like, and you can always go back up. It's like, okay, do I have all the pieces of my puzzle? Now you do. Now you can combine them. So now you add those two things up. So we're ultimately trying to find B and D. So I know B and D is just equal to CD plus BC. I know side CD was 12.6 feet. I know side BC was 17 feet. Combine those together, you're going to get 29.6 feet, which is my final answer, and I circle that. So organization is an important part of this process. So cool. That's part A, right? We figured out how wide the building is. Part B is a pretty loaded question. Part B wants us to, we have three different triangles here. We have the whole thing, we have triangle 1 and triangle 2, and you can almost say the whole thing's triangle 3, or you could call it by its labels. But basically you have three triangles classified by angle and by side length. So pretty loaded, right? So let's start going through that. So we're going to start with triangle ABC. Let me erase some of my markings here. So triangle A, B, and C, that's this triangle here, right? So first off, if we're looking at our angles here, you can immediately tell that there's a right angle, right? Because it's a straight line. So we know it's a right angle. But now we have to know the sides.
The scaling.
It'd be scalene because all three of these sides are different. We know that BC was 17. So all the sides are different. So yeah, so triangle. Here we go. So B, so triangle. ABC is a,
Right scaling.
yeah, it's a right scalene triangle. The next one it wanted us to find was triangle ACD. Yeah, ACD.
Also right scaling.
So that one there, I'm just going to scroll up for a second. The triangle, I'm going to start trying to not do the outlines now. So triangle ACD. So it is a right triangle, you're right. And we already know that all three sides are different because this was like 12.6 or something. And we also know that all three angles are different too, because we know in this one, well, this is 25 degrees, which would mean this one would have to be 65 degrees up here. So all three sides and all three angles are different. It has to be a right scaling one. And then we had triangle, I think it's ABD.
Also right scaling.
So we want to find angle. So we want to try and find angle triangle ABD. So here's what we know. We know that all three sides are different. So we know it has to be a scalene triangle. Now the question is, it's the angle. So I'm just going to quickly write that down here. So we know it has to be a scalene because all three sides are different. The question is, what about the angles? I know this one's 25 degrees, but I don't know any of the other ones, do I? And it's not an isosceles, so I can't figure this out. So I don't actually know, right? There is a right angle in here, but that's not this actual triangle. This looks like it could be a right angle, but we don't know. We're guessing. We want to take the guess out of it. What do I have to do? I have to find another angle here. Because I know all three angles are 180 degrees. If I figure out what any one of these angles are, I'm going to know whether it's what type of a triangle it is there. So I can either find angle A or I can find angle B. To find angle A, here's the thing. Remember that trigonometry stuff? Only works if I'm using right angles, which would mean I would need to find this one and this one to figure out angle A. But I can just find angle B by itself. So angle B is going to be the easier one to try and figure out here, right? There's always going to be multiple ways to solve it. I'm going for the easiest. I'm going to try and find angle B. Specifically, how do we say angle B? We would say it's angle ABC. So I'm going to find angle. So this little sign here means angle. I'm going to try and find angle ABC. This means I'm technically looking for angle B, that when it's connected between these two. You could also just say it's angle B in this case, because that's not going to matter much. So if I'm trying to find angle B here, and so I really quickly want to go back to this. Angle ABC, does this make sense what this is actually asking for?
Yeah.
Because this can get a really confusing thing. It's asking for, again, we have, like, I'm just drawing this triangle here. It's actually, it's asking for angle B when it's between these two things here. Because sometimes, like if I'm asking, if I ask you for angle A, that's asking for the whole thing. If I'm asking for angle DAC, it's only asking for this part, for example. So that's what I mean. So when I'm asking for angle ABC, it's asking for this whole thing. Okay, so I just want to make sure we kind of understood that. So we're ultimately trying to find this angle B. How can I do that? Trigonometry. Second I have angles, I have an angle and I have a right triangle, which is what this one is. I'm using ABC. I need to use trig. Now I have all three sides. So what does that mean? I can pick whichever one I want, right? Does not matter whether you use sine, cosine, or tangent here. You have all three lengths of this triangle. You can use whichever one you want. I'm just going to pick sine because why not? So what is it? This is my opposite side. This is my hypotenuse. This is my opposite because this is angle B is the one we're looking through, which means this is my adjacent. I'm going to use O and H. Sorry. Yeah, I'm going to use O and H. So SOHCAHTOA. So I know I need to use trig. So the sine of my angle, we call it theta, is equal to opposite over hypotenuse. So that step one is, again, just like before, hey, what thing are you trying to use? What formula are you using? I'm using trigonometry and I've established I want to use sine. Any would work. I don't know the angle, so when I substitute, I just leave that theta symbol in there. But I do know the opposite side. The opposite side is 6 and the hypotenuse is 18. It's 6 over 18. But remember, I do not care what the sine of the angle is. I care what the angle is. I need to get rid of this sine here. Which means I'd have to divide by sine. But again, as we established, if you take your fraction, 6 over 18, if I try and divide this by sine, it's going to break your calculator. You have to trick it. How do you trick it? You use your second function symbol. This is called the inverse. So sine to the power of -1. Again, I got that. Second function, sine. And then just put your fraction in there, right? 6 over 18. 19.4, we'll say 19.5. Actually, no, it's an angle. We're just gonna say it's yeah, I was gonna say it's 19. Let's just keep it simple, unless it specifies. Okay, so angle, so angle B is 19 degrees, right? So I'm just gonna leave that there for a second, just in case you're writing that down. I'll scroll up in a second. So angle B is 19 degrees. All of a sudden now I can figure out this angle. I can figure out angle, I can figure out angle A, right? Because if I just take 180 degrees, I subtract angle B 19, I subtract angle D 25. I'm gonna be left with angle A, which will give you 136 degrees. So my question for you is, if I know angle A here is 136, if I know angle A is 136, what type of triangle is it? Is it acute, right, or obtuse? It'd be obtuse, right? Because one of your angles is bigger than 90. So what is this triangle? It is an obtuse scalene triangle. So a lot of work to get to that information, right? But we needed some type of proof. That gives us our proof. Okay. So that's kind of going to be it for like the new stuff we're going to go through. Now, so I'm gonna cut you guys loose here for the rest of the day here shortly. Now, one thing I will say though is that these are challenging questions. These are very, very difficult questions that you're going to be kind of encountering here. So definitely ask for help if you need it. And I kind of want to give you like a little bit of a head start with question 7 here. So question 7 here is we have a bridge here and we have a whole bunch of different triangles, right? There's a lot of information on this on this diagram, right? We can see there's a whole bunch of big triangles, bunch of right triangles in here. A lot of these have the same side length. Looks like there's isosceles triangles. There's tons of information to get out of that. The question it asks you is how long is the bridge, right? So I will give you a little bit of a hint here. This triangle right here, you know it has a right angle. You know this is 11.3. And you know it's 8 tall. So I recommend start with this point, use what you know, and then start building towards it. The question it asks you is how long is the bridge? In plain English, how can you find that? If you find what I'm labeling X right now, the length of this line, and you times that by how many there are, there's 1, 2, 3, 4, 5, and 6. 6 times however long that is will give you your answer. So these are meant to be really challenging questions. You might struggle a bit, and that's fine. These are meant to be very hard. So just give it your best go here. Like I said, there's going to be multiple ways to usually solve some of this stuff. You want to usually try and think, well, what's the simplest way? But any would work. So I'll let you guys start here. So the rest of the day, you're just kind of finishing up page 185 to 188.
So for 7, you would just use Pythagoras then?
180. Question 7, that would be a Pythagoras one, yeah. At least for question A.
Right.
Oh, still recording.